Hello, Algebra 1, and welcome to 3.5, which is proportional and non-proportional relationships. Alright, let's get started. So, what is a proportional relationship? Well, it's a relationship that fits these three criteria, and it has to fit all three of them, so you might want to take note. It's linear, which means it's going to graph a line. It can be written in the form y equals kx, and it always passes through 0, 0. Okay, so here we have the volume of water and ice. So on the x-axis we have the volume of water, on the y-axis we have the volume of ice. So if you have no water, it's going to freeze into no ice. So that would pass through the origin then. And then so they've plotted some points here for us. They're from our table down below. 11 cubic feet of water freezes into 12 cubic feet of ice. 22 cubic feet of water freezes into 24 cubic feet of ice. And after they're plotted, we notice that they are linear. And we're going to work on writing it in the form y equals kx here in a minute. So, using deductive reasoning means, can we use some knowledge that we have to see if there is a pattern or to see if there is a relationship? Okay? So, does there look to be a relationship between the amount of ice you get depending on how much water you freeze? There it does. Alright. Alright, so we're going to look at an example. Here we have a table that shows the number of miles driven for each hour of driving. Notice I did make a correction to the table, so if you printed off the notes, you might make that correction in there. And we want to graph the data to begin with. So the first thing you need to ask yourself is, does hours depend on miles, or does the miles depend on the hours? The miles depends on the hours. If you have a time, it is always the x-axis. So let's go ahead and label that. We have hours, we have miles. Alright, so we just want to plot these. Oh, hold on one second. We need some numbers, don't we? Always make sure you write how you're labeling these. So if we just, let's say, that's going to be 0, 1, 2. I'm going to spread it out a little. Sometimes it's easier to see. And this time, with this one, we'll just count by 50s. Okay, so now I know what I'm counting by. Let's plot those. 150, 2 100, 3 150, 4 200. Alright, so what conclusion can you draw? Well, you might draw a conclusion about, the longer you drive, the further you go, okay? And in this case, we want to draw a conclusion that this is a linear relationship between hours and miles. Alright, so since it is, we can write an equation in function notation to describe this relationship. So function notation, remember, is f of, so in this case, we're going to want it to be f of h, because it's in terms of hours, that's our x. Alright, well, so how much do I go up every hour? I go up 50, so then it would be 50 h. So in 1 hour, so to check this, in 1 hour, I go 50 miles, right, because I take 50 times 1. In 2 hours, I take 50 times 2, which is 200, or 50 times 2, which is 100. In 4 hours, I take 50 times 4, which is 200. There we go. Okay. So, same thing again. Why don't you pause the video and see what you can come up with and see if it matches mine? Okay, so I labeled my graph. I had t-shirts on the X, cost on the Y, because the cost depends on how many t-shirts you order. I went ahead and graphed them. It is linear, and you always need to make sure it's going to go through the origin. So if I order 0 t-shirts, I'm going to pay 0 amount of dollars. And then to write my function, and I just kept it as f of x this time around. You could have also used f of t. And each t-shirt costs $7.50, so I'm adding $7.50 each time, so that would be 7.5x. Okay, moving So those were proportional relationships. They always go through the origin. But I can have a linear relationship that doesn't pass through the origin. So that's what we're going to call a non-proportional relationship. And it has to have some constant that we add or subtract that moves the graph up or down. Okay? So, write an equation in function notation for the relation graph below. First, make a table of ordered pairs, find the domain, range, differences, and finally write an equation in function notation. So this second bullet right here is telling us our steps for how to do this. You probably want to have those steps written down so later you can duplicate it. So my table of values, okay, so there's x, y, so it goes in here first. We have 1, 1 it looks like. Okay, notice they're counting by 2's. Then 2, 4, okay, 3, 7, 4, 10, 5, 13, all right. Find the domain and the range differences. So what is the x-axis counting up by? Counting up by 1's. What's our y-axis, our y values counting up by? Those are counting up by 3's, okay. So we want our y-intercept because that for a proportional it goes through 0, 0, but in a non-proportional the y-intercept is what has changed. So if I count back, I'm actually going to draw it like this, but I want to count backwards to where x is 0, what would y be? Follow your pattern. Y would be -2. So there would be a point right here. So f of x equals, well, first of all, we're going to do our, every time you do x increases, we're increasing by 3. So it looks like 3x minus 2 because we have to shift the whole graph down 2. Okay? I know you guys have done slope before. Essentially, there's your slope, there's your y-intercept. We're just not calling it that yet. Okay, one more slide. Write an equation in function notation for the relation shown in the table. So without a graph, can you write an equation or in function notation for this table? So you need to do what we just did on the last one in terms of writing the differences. So what's happening to the x's here? They're going up by 1. So if I came back 1, I would be at 0. So what's happening to your y's? They're going down by 1. So if I came back 1, where would you be? You'd be at 4. So f of x equals, but each time I'm going down 1, so -1x plus 4. Okay. Now, I would advise you once you've written a function, these are really easy to test. What is f of 1? I know what I should get for f of 1, but if I put in a 1 for x, -1 plus 4, okay, that worked. Maybe try f of 3. This is something that if you are uncertain that you have the right answer, all you have to do is plug in some values because you know what you should get. Alright, that's all I got on 3-5. Make sure you've taken good notes. If you have questions, we'll address them in class, but at least you have your notes done. On top of that, since I've tried a new format tonight, right now go to the blog and I want you to write a few sentences. It needs to be kind of lengthy, not paragraphs, but more than just I liked it. On the new format, if you think this will work better, if you liked the other way, this app is called Explain Everything. The other app is called EduCreations. I just want your feedback. If you do that before your next class period, I'll give you 5 points of extra credit towards your semester extra credit. All right, let me know if you have questions. We'll see you later.